Hello everybody and welcome to another Unity game development video. Today I will be talking about one of the features in my game. It's not so much as a feature as much as it is kind of like a technical thing that is interesting. So it's not quite as interesting feature-wise as, say, adding a grappling hook to the game or, talking about how any of the physics systems work. But this is something that I think a lot of people often have issues with when designing kind of character controllers. If they don't want to download them from, say, the asset store or follow a really long, tutorial to figure it out, they have the issue with going on slopes. And don't get too excited looking at these stairs here because this is not a script used to kind of overcome the limitations of a rigid body in which we'll be adding forces to get characters to go up and down over, small edges. That's not really what we're going to be talking about today. Today we're going to be talking about how the character will be handling slopes in a different way. And what I mean by that is on the screen here, it may look like there are steps, but essentially this is just a ramp. The steps are only cosmetic. It's as much as a ramp as those ramps over there. So don't pay too much attention to the steps. I just add those for aesthetic reasons. So basically what I have here is a script that allows me to use a rigid body controller to move smoothly on a surface such as a ramp. And this may be something that you've seen on tutorials on YouTube and something they kind of overlook. Specifically, I was looking at something there was one that was kind of recreating the movement system on slopes for World of Warcraft, and this is completely reasonable because, maybe that's not how World of Warcraft behaves. But that and one other one that I'm trying to think of right now didn't exactly give a situation in which the character would be able to move up the slope when not looking directly up the slope. So I can move up, down, I can move sideways up and down the slope. And that's essentially happening because if you look in the scene view, I have an empty object called a move vector reference, and that is following everywhere the player goes. But more importantly, it is determining the angle of movement for the player. If you've watched any of my other videos and my old movement videos, you'll be familiar with the concept of this object because it's essentially an object that is sticking to the player, and its rotation on this axis, on the y-axis, looking around, is completely based on the rotation of the camera. So its forward vector in that instance is the same as the camera's, but what we are doing now is we are modifying the angle so that it can adhere to ramps and things like that. Because otherwise, without the extra code in there, if I'm looking in this direction and I hold forward, I'll move off of the ramp and then fall forward, as if it was adding a forward vector. But now it is applying a vector along the angle of this ramp, and it's a lot more important. If you look in the scene view, you can see no matter what angles I'm moving on it, it is kind of adhering to it and moving around. The only way it really messes up right now, and let's see if I could do it, is if I run up here really fast and then spin, my character will fly off of it. And that's like a very, very specific use case scenario in which I'm not sure how often a player would even run into that. I might look into fixing that, but that might also be some bit of movement tech that is interesting. So that's not really an issue right now. I'm just going to talk about how this movement, vector reference object is changing its angle to adhere to this ramp that we have here. So basically, if I go out of here and I go into the code, we have our one incredibly bloated script that is handling all the player movement, and that is called player move. And I have a few notes here, 3 notes that I've labeled here with the finding thing. I've been trying this recently, and I suggest it for anybody who wants to kind of start making videos is notify your, like put notation on your scripts and put easy ways for you to go to each chunk, especially if it's such a big bloated script like this. So I've noted 3 things, and we can move between them by just using the finding function. So the first note is here on the onSlope function is being called, and we'll check out that function in a second. If we go down to it, here we go. And instead of doing that, I can just go to the note. That's why it's there. And we are here on this line of code. OnSlope is a function. It's returning a bool. So we are establishing a bool called slope. It is immediately being initialized as false. And then if the circumstances change within the code, that will change it to true. It'll return true at the end. If not, it'll remain false, and that'll be what will be returned at the end. So this function serves the dual purpose of telling us if it's on a slope and performing the logic written here. So we are sending a raycast downward. We are hitting the kind of normal that we're standing upon. If we're hitting anything that isn't tagged as the player, so that's useful because we have a lot of objects within the player. We have a complicated player in this game, and we don't want any of those objects to be hit. Otherwise, our script will be rendered useless, and it will determine that that is ground when it is not. So if the slope rate hit, if the normal that is being detected is not equal to vector 3.up, so that's a very simple thing that we have set in there. Most scenarios you won't be walking on perfect ground, but in case you are, we're not even going to try and check. Slope is going to be set to false. So if you're not walking on flat ground, then it's going to say there's a slope. We are determining a slope angle, a forward angle, and a right angle. The slope angle is using the vector 3 angle function, and it is the angle between directly up and the normal of the slope that we are hitting. The forward angle is the angle between that movement vector reference object that we have, its forward vector, and the normal that we're hitting. So we're basically getting that forward angle. We're getting the angle in the direction of where we're looking on the slope. And that right angle is the similar kind of function. We're getting the right vector instead of the forward one, and we're getting the angle between that and the normal. We're subtracting those by 90 because we want a particular vector that we're just kind of turning at 90 degrees. If we are not detecting any kind of object beneath us, then we're just going to set those values to 0. And then basically what we're doing is we're taking that information and we are going up to the move vector reference and we are applying it to its Euler angles. So we have, or I believe they're called Euler angles, right? So I'll probably switch between them, but in this video, the movement vector reference Euler angles are being set to a new vector 3. X is going to be the Euler angles of the vector reference minus the forward angle. So we're taking the kind of like twist or like rotation of that current object, and we're subtracting that forward angle that we're getting from that script. And we are taking the Euler angles of the movement vector reference object, which is a completely different empty object on the player. And we essentially aren't really doing anything to that, but we may mostly get this object because it retains that kind of Y angle where the character's looking around and everything, but it is not receiving the kind of iterations that are being enacted on it with these forward and right angles. So if we were to get the movement vector reference for the middle object, how we are applying these to the X and Z of this particular vector will actually affect this one. So we're getting those angles before those are applied. And then we are applying the right angle to the Z Euler angles. So essentially we are taking those angles, that floating point value that we got from the onSlope script, and we're applying it to the X and Z values on this Euler angles for the vector. And essentially when all that is done correctly, we get out here and we get what I showed you on there before. So how the script is taking that is we are using this kind of object and how it's rotating, and when we apply a movement to it, we are applying it to that angle. So if you had a normal player that was just standing normally like this and we applied a forward vector to it, in reference to the character, we would just move them forward. But if we are on the slope, we are applying that forward vector to this new empty object. So as you can see, looking at the Z, the blue arrow on the object, that forward vector is now aligned with the slope. So it's going to push us down instead of forward. And I am just kind of pointing out where that is on the object in the hierarchy, because if you remember, I have very complicated look scripts that use several parented objects. And I just want to show that this is just an object, an empty object that is within the player object right there. There is a line of code within, the script that I didn't go over, and it's literally just taking that object and applying its locational transforms to the player. But that's not really important. I'm sure you know how to make an object copy the position of another object. But essentially, that's all we have to go over. So hopefully this helps. If you are having any issues following and wondering how kind of the movement script works with the actual movement vector reference, I guess I could go over it right now. If I go into the script, and I guess I'd open in Unity. If I go into the player movement section of it, we have all of our inputs. We have horizontal input, vertical input. I go over this stuff in a different video, but essentially we are taking the vector reference and we're changing those angles like we showed. And then what we are taking is the forward movement of the object as described by these input variables and how they interact with the rigid body, and we are applying those to the movement vector reference right here. So we're taking that forward movement and is equal to that move vector reference dot transform dot forward times the vertical input, and the move vector reference dot transform dot right times the horizontal input. So we're taking that basic movement script and we're applying it to that object instead of the player. So we're getting the directions in which the player will move dictated on whether it's on a slope. And as you may have seen in an earlier episode of my FPS project thing, how it moves in relation to just, moving on a wall or something like that. Moving on a wall or something like an obstruction. So hopefully that was helpful, and hopefully you learned something from it. Also, if you liked what you saw, please subscribe here on YouTube. Follow me on Twitter, on Instagram. I've got everything in my link tree linked on the YouTube, linked in the Twitter. Everything is everywhere where you can find it from each other. So just go to my account. You should be able to see my link tree and all my other stuff on there. Thanks for watching, and I'll see you in the next video.